At the conclusion of this video, you should be able to determine the displacement of the object from the position time graph, determine whether or not the object is accelerating from the graph, and use the graph to determine the velocity of the object at any moment. Here's a position time graph that we can look at, and we want to answer those three objectives. And what is the displacement? Is this accelerating or not? And can we find the velocity at any moment? So first question is, what is the displacement? Well, usually with the displacement you have to specify the time interval. So for this one, let's just ask, what was the total displacement? That's a real common question, for example, on a test. Well, since displacement is defined as the final position minus the initial position, at the very end its position was 13, at the very beginning its position was 3, and so obviously the displacement is 10 meters. If you had another time interval, let's say between 4 seconds and 2 seconds, it would just be a matter of taking those two positions and subtracting them. So to find the displacement, it's quite simple. Simply find the two positions and subtract them. What's going on between those two positions is irrelevant to answer that particular question, and that's important to remember. Now the second question was, is this an accelerating motion or not? Well, we'll answer that a couple ways. One, we look over here and we'll notice that for every second your position changed by 2 meters. Well, since it appears you're never getting any faster, otherwise your distance during that time interval would change. So just from that I could say that this is constant velocity. We're also going to find out that the fact that this is straight is going to be a very simple way of knowing that this is an example of non-accelerated motion or constant velocity. Alright, now the really important question for a graph like this is, what is the velocity at any particular moment? So for example, what is the velocity right here at the 3rd second? We know we're at position 9, but how fast is it going right there? Well, to do that, we actually are going to look at the slope of the line that passes through that point. And since all these points actually are on that same line, this one's going to be quite simple to do. We know that the slope is going to be equal to the change in y over the change in x. So in this case, let's pick a couple points here. Again, let's use this one and this one. So this one, it will be 13, and this one here is 5, and here the time was 5, and here the time is 1. So now we have 8 over 4, which of course ends up being 2. But what are the units of the slope? That's something not talked about in your math class, but very important here. Well, since this is meters and this is seconds, that obviously ends up being meters over seconds. So the answer is 2 meters per second. But we know that meters per second is a velocity. So this tells us a very, very, very important concept that you need to memorize, which is that the slope at any point along this graph is the velocity at that moment. That will always be true for a position time graph. Let me say it again. It's so important that you know this. Anywhere on a position time graph, the slope at that point is the velocity at that point. Well, here we have a completely different looking position time graph. This one happens to be parabolic, so we have learned already that the equation for this function is equal to the initial velocity times the time plus 1/2 at squared plus the initial position. So that's a formula of our parabola. First question is, what is the displacement? Well, the answer to that is done the same way it was before. It doesn't matter what the shape of the graph is. To find the displacement, find the two positions, take the final position minus the initial position, and that gives you displacement. So in this case, the final position was 18, the initial position was 3, so the displacement was 15 meters. All right. Second question is this accelerated motion or not? Well, we can get that answer quite quickly from looking at this. If we have this data, we notice that in the first second it travels 1 meter, but in the second second it travels 2 meters. So it's obviously going faster. In fact, it went twice as far, so its average speed was twice as much. But in the third second, it now traveled 3 meters. So this is obviously traveling at a greater and greater rate of speed. But the big clue, if you don't have the data table and you just have to look at the graph, the curved nature of this graph tells you that it is accelerated motion. If this graph is straight, diagonal, horizontal, doesn't matter, then it's constant velocity. But if it's curved like this, then it is accelerated motion. The final question was, what is the slope at any point? Because we just learned that the slope is the velocity. The previous graph was easy, there was only one slope, but in this one the slope is continually changing. How do you find that? Well, you draw a line tangent to the curve at any point. So if I were trying to find a slope right here, then I could try to draw a tangent line through that point, and the slope of that line would have the units of meters per second, and so that would be the velocity at that moment. Well, you notice if you look at some of these shapes here that the slope is increasing in positive value. Down here it's a smaller positive number, and up here it's a greater positive number. This tells us that the velocity is becoming a greater and greater positive number. In calculus, you would actually do something called a derivative to calculate this value. We used our calculator just this week in the lab, where the calculator told us the value of this. We will also find out that Logger Pro can give us this value. And so we have different methods that we can actually find the value. But the main thing you need to worry about is that there are changing slopes, and you need to recognize that in this case, the slope is increasing in the positive direction. So in summary, if on a position time graph you see a straight line, which could be a up diagonal or a down diagonal or a horizontal line, that's going to mean constant velocity because there's only one slope. If, however, you have a curved line, here are a couple that curve down, and here are a couple that curve up. Those curved lines always indicate that there's a changing velocity because the slope is continually changing. And of course, changing velocity means we have accelerated motion.